Hello, my name is Paula Schultz. We're going to be working with a model called Heatbugs today, and we're going to use this to try and learn how to trace logic in a program. So in the models library, there's a model called Heatbugs. So we're doing this. This isn't one we'll have later in class, but all the principles do apply. Open that up. All right, so good initial habits to start out. We're going to go ahead to Tools, Behavior Space, New. This will actually show all of the initial the variables and values. So we're going to go ahead and highlight all of that, copy it, and then back out of here. We can go ahead and set up a new button. We'll put it right here. And then we're going to go ahead and call this reset. Now we have to do a little more work on this one because there's a lot of variables. So basically what we do for all of this is we're going to set each variable to what the default was when we opened up the model. Makes it easier in later runs if we want to return to everything. So in NetLogo, that's just going to be set. So we're going to have to remove all the quotes and the brackets. It's a little bit cumbersome, but not bad. We can speed that up just a little bit by judicious use of copy, paste, and yeah, still got to make sure we delete the other stuff we need to, or it will throw an error. And because I'm not 100% sure I got everything right, I'm going to go ahead and Control A, or on Windows anyhow, select everything, and copy that just so I have that in the clipboard in case I need to fix something. So let's check. Reset button seems to function all right. All right, so we're going to click and drag and move that just so it's lined up a little bit better. So just to double check the function, if we change all the sliders to something else and go ahead and hit reset, all back to normal. Now, since we are already playing with modifications, a really good habit is going to be to save it as a new file just so that we don't have to worry about it. Uh, so I have it in my video exploration file folder and Heatbugs exploration. If you want to change this to tweak or something, just so you know that it's not the original version you're working with, since the reset button is already modifying the code. Right, so now we have it saved. You can see the new name there, and we'll go ahead and take a look. Info. This one gives us some good information on things. We can talk about how it works. This one is about bugs. Trying to keep to the right temperature. They don't want to be too hot. They don't want to be too cold. They can choose to move. Uh, yeah, yeah. And some bugs will put out more heat than others. So, well, we have the bug count. We have how quickly the world cools off. So this could simulate how insulated it is, how much wind there is, other external conditions. How quickly heat at one spot in the world diffuses to others. So, for example, if we're in air, this wouldn't be the same as if we were in water. Minimum and maximum ideal temperatures, so where they're comfy and happy. How much heat they can put. And then since you can see here, minimum and maximum heat that they can generate. Each bug is given an output heat value between minimum and maximum. So there's another source of randomness. And they can also have a chance to move. So they will move to get to a comfortable temperature. And they also might move um, even if there are no better patches, possibly, based on that. Deep freeze cools everything up. Heat up cranks everything up. So we can take a look and see happiness, sadness, and all of that. So we got things to notice and different descriptions here. So we're going to go ahead and play with this right quick. So setup procedure. Notice that there's color differences, and this one actually has some really nice functions to change which color. So you can watch happiness, saddest, happiness, and ideal temp aren't really calculated because we haven't started it yet. Right. So if we hit go, we can see everything is shaken. So they're moving really fast. So if we take a look at the turtles, sorry, a little bit hard to make out on here. Output heat is 22 for turtle 81. Turtle 6 here is output heat of 14. So they'll put different temperatures out so we can see some of that variability. So they have a minimum ideal temperature, maximum ideal temperature, minimum output heat, and maximum output heat. So some of them will be more comfortable in some spots than others. So we can click ideal temperature, happiness, so we can see how there's a lot of less unhappiness once they get to move around and select things. Whereas if we start from the beginning, they're not always super happy. So I'm going to slow the speed down on this model so we can watch things a little bit more. See just a little bit how the different temperature spots interact and how more of them are getting happy. Now, the saddest one is looking rather dark. The happiest one is looking rather light, so that's how the color scale is going. And the saddest one can't really seem to get anywhere. If we take a look at the turtle, we can see that they don't, oh, they want to be really warm with an ideal heat of 36, but they only put out 6 heat. Oh, and their happiness is going, or unhappiness is going down if they get closer to something else. Yeah, they're still, they found a friend. They're trying to follow the friend. So we get to see this really cool behavior where it's trying to stay warm and reduce its unhappiness, but the friend has an output heat of 19 and an ideal temperature of 17. So it's already hot enough all by its lonesome. So that gives it some issues. Now, if we change the evaporation rate, so how quickly the world cools off, let's see if any of this shifts. All right, so unhappiness seems to be, ooh, everyone's unhappy, isn't it? Everyone's just a little bit colder and they can't put out quite enough heat to stay warm. So one thing to keep in mind is with some models, you can play with things while they're running. Some of them, there'll be initial settings. This one actually marks out the differences, which is kind of nice. All right, yeah, no, we just made everyone miserable by making it too cold. Someone needs to close the window, I guess. But yeah, we can see who is least unhappy starts to have some more options here. So this model looks complicated, but it's not really. We'll go ahead and work through some of the logic now to see. All right, so we have the code. We have a global variable, color by unhappiness. So globals are there. And then on the interface, we have sliders for count. No word. I don't need you to autocorrect that. Thought I turned that off. Undo automatic capitalization. There we go. Min ideal temp. And you could copy and paste by right clicking edit global variable, but this actually might take longer if you're a decently fast typist. I'm okay, I'm not great. And on this, we could even document because the program does differentiate initial settings for bugs. There we go. So highlighted and shifted that a little bit. And then for parameters, operation rate, diffusion rate, and the move channels. So we can start to pick on what all of these are for. So based on the context of the model, we know this is how many turtles, bugs, or whatever you want to put it as, lower end of potential range for ideal temperature. So we can take a look and notice, both here and in the code, that each turtle will have a specific ideal temperature. So the range is for what that can be set to, not the turtle will be happy within a 5-degree range, for example. So this creates some variability, but it's one that's embedded slightly differently. So if it's 1 degree off, uh, oh, actually we can take a look at the code and see how it's described. The magnitude of difference between my ideal temperature and actual current temperature. So to reach peak happiness, it needs to be at just the perfect degree, whether that be like 68 degrees Fahrenheit or 72 degrees Fahrenheit, or 34 degrees Fahrenheit. That varies a lot. And we're not worried about exact measurements in this context because that's not the point. But we can see how that's per turtle. And then this one's going to be the higher end. All right. And then keep that language consistent. So pretty easy. And we can see based on the code, this will all set it on a per bug basis, since we can see ask n of bug count patches. So that's trying to create only one bug at most on a patch to start out with. Sprout 1, which creates the turtle. Set ideal temperature. So this will be on a every bug basis. So it'll be the minimum plus a random number times somewhere in between the max ideal temp and min ideal temp. And then it also does the same for output heat. So we can see right here we have some sources of stochasticity without having to really work through anything else there. So still documenting the interface. So we see evaporation rate, diffusion rate, random move chance, and we have all of this under sliders. Uh, Word is such a pain in the butt about lining things up sometimes. It's the count of the one. Oh, this is annoying, but it goes to show some of the joys of word processors. Okay, that was a little annoying, but just a reminder that Word will frustrate all of us, not just students. Me and Excel have a strong hate relationship as well, so you are not alone. All right, so we have initial settings for bugs. So we've described sliders. We'll go ahead and go with buttons. Now, default on there. Oh, you stupid program. So this might be the easiest way to do it. Right, if you do a space after an empty point, it will hold it so you can then tweak it and deal with it later. Right, so we have buttons for actions and buttons for color. Yeah, we'll go with that. And if you already have a given outline, you can always change this to, it's better to suit what format you're given. We're doing this from scratch, so we'll just call it a day with stuff like this. But the actions will be set up, go, stop, capitalizing, reset, so deep freeze, heat up. And then this one was added to set to default values. Setup and go are going to be pretty common in most NetLogo programs, so up to you on defining that. The deep freeze, drop all batch temperatures to 0. Heat up, make sure I have how it's set up. And max. Oh, okay. So this actually specifically adds heat from max output heat. For watching, we got calibration. Okay. So these will override the prior one, so we can go ahead and group that. And then watch saddest or happiest or reset perspective. And they're separate buttons, but they're all performing functions in the same way, since just clears the watch. So we can group that. And remember, just a little space lets it stay there. And then outputs. Plot of average bug unhappiness. And we can always add more to that, but that's a different exploration. And if we add some spacing, makes it a little bit more readable, which, is kind of the point. All right, so we have globals, interface description, sliders for initial settings, other parameters. If you want to move all of this over, we'll try and do that. Okay, so it needs a blank one or something else to pin it so it doesn't try to change the type. Button. All right, so there we go. So we have initial settings, other parameters. So all the sliders are documented, buttons with which actions they take. Some of this can be grouped by function since that all makes sense and makes it easier. And yeah, and then the output, which is going to be the plot here. And we can take a look at that and see it plots mean and happiness. If we want to go ahead and add something else, we should be able to do the max. Let's see. Does max do it? Yep. So that'll be the happiest. So making the colors contrast a little bit should be good. We'll go ahead and do a little pinkish since, well, we're in February, so Valentine's, I guess. And then we can also go ahead and there's a function for min too. And we can go ahead and put that as, we'll do that as a yellow for contrast. Or yellow might not be enough contrast to see on this, so tweak that. That might depend on the mode. If something can't be seen, it's not particularly useful. There we go. So no bugs are like completely miserable, and some bugs are really happy. A lot is average. So that gives us a little bit more detailed look on how that goes and how we tweak that. Now, if we do deep freeze, I'm going to slow this down. We can see everyone gets, oh, kind of a bump in happiness. All right. So they might have been too warm. Now, if we do heat up, everyone's unhappy. So there's no peak happiness right now. But we gotta wait for it to cool back down based on the evaporation rate. Cool. And we'll just reset everything to default and go from there again. But we have added to our plots, so we can also document this on there. Average, max, min, bug unhappiness. Right? And I don't need an extra there now, so we'll go with that. So that's a good way to document the interface. We'd also want to put a description of the world. So let's go ahead and do that right quick too. Oh, okay. That's interesting. So it starts the origin from the corner. Not a big deal, just how it does. The world design is 100 by 100 torus. And patch size is just how it looks visually. Frame rate, yeah, all that we don't need to worry too much about. But yeah, you can notice how this isn't centered with a center origin, so that just changes the way we read the numbers. Whereas if we put it there, it would change the size, and this would double the size, or sorry, quadruple the size. So we don't necessarily want to do that right now. All right, so we got a different way to document. So you can see how this shows how to use, but it's not really documented in the same way we were doing with the Flocken model, for example. Now, we'll go ahead and dive into the code right now and take a look at some logic and just see what we see. So we have the globals, we have the turtle variables, which we can, I'll go ahead and put this below interface just so we can work on it as we go. Turtle variable would be ideal temp, output heat, unhappiness, touch variables. All right, and then features setup. All right, so this will be clear all. We're going to over document first and then set color by unhappiness to false. So this is a Boolean variable. If you'll note it, if you know the difference between that and a number variable or character string variable, so this will have a value of true or false. In NetLogo convention, this will end with a question mark that is very, very, very program language dependent. Sorry. I have very, very, very mixed feelings about it. See if I can fix that. This will automatically does it in the most annoying way possible. So defaults to there. Mm, be annoying. This is annoyingly inconsistent. Anyways, yeah, I tend to be very forgiving about format errors here, and this will be part of why eventually you'll want to learn other um, formatting structures. So anyways, so there's the setup function for the first part. All right, and then ask patches to sprout, just create turtles, one per patch, as we can see by the sprout one. Set ideal, set temperatures and color, and face a neighbor. So they all have direction that's based on that. And increase, which is only for visibility. On most programming, it doesn't actually affect how anything runs. Um, the collision mechanics are kind of specific and that can vary, right? So there's the setup, and then we set text. Tab. All right, and then the color by ideal temp. Just manually do that because it's annoying the heck out of me. All right, so that'll set that color to temperature range. Oh, sorry, adjusted for temperature range. Whereby, and then set color. Oh, okay. Double check on that. So see how it has unhappiness compared to max unhappiness scale function. All right. What is max unhappiness? All right. So Control F in Windows will let you find stuff. Oh, okay. So this I don't love, but it's good to notice. So you see how it says the color by unhappiness. So it finds the highest unhappiness of the turtles each time. So it's not a constant. Uh, so we can put a note in there for ourselves. Scaled to unhappy turtle. 0 to most unhappy turtle. So we can notice that behavior color-wise, even as everything becomes happier, yep, for now, reach an equilibrium state, the colors don't change near as much because unhappiness is there. So we can take a look at the shade shown here. Whereas if we did that, right, we're going to tweak this, comment this one out easily, and then also put a comment at the end, original function. All right, and I think, by the way, without having to look this up, it'll set color, scale color. So the color is going to be blue, scaled based on unhappiness. Max unhappiness would be the highest. Uh, what values do we have for max unhappiness as we run, actually? Oh, okay. So the highest starts at 40-ish, it looks like. 40, 45. So this will tweak, and we'll have to see how it calculates unhappiness to get a better variant. But for every run, we'll just go with that. So we'll just fix it to 50. So we're changing this to a constant. So now if we're looking at happiness, everyone's pretty happy. Whereas if we go, so this gives us, I slow it down a bit. So if I freeze everything, you can see everyone gets back to unhappy really quick. Everyone stays miserable if it's hot too. So if we change that code back, which we can just do comment, uncomment, we can take a look for everything else being equal. Because everyone is in a similar state, there's less color variation. So now, if everyone is equally miserable, wow, we can get people extra unhappy. We just set everything on fire. Um, yeah, so you can see there's a lot less color variation on there with that scaling versus the modified. I'll stick with my modified. I kind of like it a little bit better. But this also depends. What do you want it to compare against? Though I actually might go out of range with, oh, let me change that to happiness. That would help. Yeah, so everyone is incredibly unhappy since I kind of went out of the color scaling. They're all a uniform color now because everyone's miserable. Good times. All right, so I tweaked that. That is why it's there. If we're documenting existing, I wouldn't want to do that, but you get to play. All right, now we got that. All right, and if not any turtles, it'll stop. I don't think there's a function for turtles to die. So that one might be an artifact of something else. Uh, but it's a stop condition we could tweak later. All right. So notice this one is an if statement. So we're actually going to go into the logic. So this will be less document. So this is less nodes, more logic. So we're going to work through what a step will run. All right. And then if no turtles, stop. Now note, since this is an if statement, there's no else, so it'll stop or it'll just ignore it. So that'll be implied, and I'm writing out extra for y'all. Implied if turtles go functionally equivalent to, I'll even do code snippets and highlighted so it's there. As we go. If not any turtles, stop. Extension equivalent. And if else, not, sure I'm getting the logic right. Else not in turtle. Yeah, we're trying to keep track of the brackets can be something. I forgot what NetLogo's equivalent of continue is. Let me actually check. Oh, dictionary. Okay, so that doesn't give anything super handy in that context. Alright, if else, alright, say we're going to head and create another global in the brackets, extra tick. This will be a duplicate function because, yeah, I don't want to type that again, so copy and paste. Oh, and then I would want to add setup. Do that after clear all. And there are times when you would want to do something like that. That's fine. So that'll be an extra tick counter. So we can do that. Make sure that's right. Setup. Show. Right, and we can see that matches because it's a tick counter. If we change that to +2, we can see how it's double the tick counter because we do a +2 each time. So you'll notice in this test that the flow logic has two sections with brackets. First one is going to be the if. If that one doesn't happen, then the second one is processed. Now, everything in here is one segment. Do not love the way that has that format. Is there a style I can change that to that will make that less annoying? Oh, here, we'll go with that. So one thing to keep in mind is any indents are purely stylistic and not required. This is not Python. Python is different than many other languages in that So right now, I don't have it indented. I can, which will make it a little bit more. What are you on about? Right, so I had to do space instead because it's supposed to indent automatically somehow, and it's kind of flaky. Alright, so you'll notice that this is one chunk. Diffuse temp diffusion rate. So that will call another procedure, I believe. Or is that a built-in function? That is a built-in function. Oh, okay, so that's a built-in function to spread things. Cool. New temp fusion rate. So that will spread things. Um, A little bit. Tells patch to give shares to its 8 neighboring patches. Alright, yeah, okay. That will spread the heat. Task patches to set temperature to temp by evaporation rate. So evaporation rate is the cooling function. Alright, so then try and keep the styles consistent for you all, sorry. Free. I'll do hidden free for the actual code. Um, you can see where all of the styles can get really confusing. How is that? Microsoft Word will have a lot of swearing involved, I guarantee this. Right now, ask turtle step. Equal, equal, equal. Right, so those are different procedures we can see because they aren't stock ones, I don't think. Yeah, so we have those procedures. And then tick and put section marker, not a stop condition. Now to keep in mind that that marker, if we have to go on a wherever versus go on a step, which we've integrated in other code, that will change how that's treated. If go wherever, up again, step. All right, so the most important function we're going to do for now is going to be the step function. So we can copy and paste that. All of that to click style to match. Yeah, so this one is well documented in the procedure. Take one step. Yeah, just going to delete all the comments just so we're working with only the code for that. Okay. All right, so this sets unhappiness to difference between patch. That was variables for the totals, right? Oh, no, so it is on patch temperature. Okay. Control, video, and all right. If the unhappiness is greater than 0, okay, and that's actually one thing to keep in mind too. So, note, field temp is owned by turtle. Temp is owned by patch. Is we can double check that by taking a look at inspecting the turtle. See, sorry for it being a little small. So it has an ideal temp, whereas if we inspect the patch, it will have an actual temp. So we got the step function, which will, sorry, coming back to that. So unless the turtle is perfectly happy, which is unlikely in the model, but possible, uh, it'll have a if-else random float. So taking a look at the code, step function. All right, so the if unhappiness, this is all one separate block. One of the things to note and keep in mind, if unhappiness equal to 0, then nothing in this block happens. Regardless of result, it will happen. Continue unless there is a stop or something that breaks this particular run. Right. So now we've got that entire block. Now if else is this block. So you'll notice that the brackets here, I'll go ahead and highlight that a little bit more. So keeping track of brackets is a pain because these brackets are for the entire if statement. Make a note there. Oh, I've been recording for a while. Sorry about that. So these brackets are for the entire if statement. This is for the if else statement. So if else, we will go ahead and have, alright, so it's a random check to see the chance on there. So regardless of, or yeah, so, okay, yeah. So if they're unhappy, there'll be a chance between them moving towards the best patch they can find, or if they just move to one of the neighbors randomly. I'm not sure that's implemented correctly, which happens on occasion. Okay, looking at this, I don't believe that the random move chance is actually implemented correctly. Not according to the description. So this will, unless, regardless of, it's implemented kind of loosely, but alright. So this makes it so that the bug will either move to just one of the neighbors if random move chance was at 100, which is yeah, at its maximum value, then it will always just move to one of the neighbors without trying to see which patch is better. So that phrasing is a little bit odd. Selected, right? Selected, and choose best patch. Right? And then we'll have the reporter for best patch be lots of logic. I mean, bump this out to a shorter version. So if else temp, so we can take a look at where everything is here. And you'll notice there's actually a small little highlight here to help with that. Right, so we're looking at that block and that block, which are for this if else, and then this one here, which is for that entire block. So this is the first one of this section, and this is the second option. Oh, does that do that? So taking a look at where the brackets are, on this is choice one, is choice two. Is need in these functions else. So please don't send me stuff with this much color normally, but this is a good way to identify it out a little bit. Right, so now if we have red, so we're still within this section. So this is the second. So this is the first option, as we can keep with the brackets and the color. This one is the second, and then we have a second if else within. Okay. If for that is that's a little annoying. This will do the darker red, and here we'll do. So that hopefully gives you a good visualization on the logic flow here. I'm going to go ahead and cut that one short since I wandered a little bit, and I will mark a couple of key features. But this gives you an idea on how to walk through the logic step by step and how to document. If there's any other questions, or if you do want me to continue on anything else, let me know. Uh, but you can kind of see the idea on here where, yeah, different checks, different workflows, and everything to go through. Thank you for watching as much as you did or not, and have a great day.